Systems of equations, elimination. Elimination is one of two methods for solving systems of equations algebraically. And as you saw in the last video, that means we will use the equations to solve. Eliminate means to remove something. And that is exactly what we're going to do when we use this method for solving a system of equations. Systems of equations problems suitable for using the elimination method have their corresponding parts lined up vertically when we stack them. We'll stack them right on top of each other. Our first step when using the elimination method is to determine which variable we will eliminate. After that, we will determine if we need to multiply neither, one, or both equations by a number to accomplish the elimination. Finally, we add the two equations and solve. Let's look at an example. I'm going to take this red and blue equations and I'm going to stack them right on top of each other. So I'll have the first the 4x plus 6y equals 18 and 10x plus 3y equals negative 15. So these equations are suitable for using the elimination method because I have my x terms and then plus or minus, my y terms equals some number. Right? Now, if I just added these together, I would get 14x plus 9y equals 3, and nothing would be eliminated. So I need to multiply one of these equations by something in order to eliminate. And what I'm going to do is I'm going to look at the coefficients. 4 and 10. It's not easy to multiply 4 by anything to get 10. 6 and 3. I could multiply 3 by 2 to get 6. And that's what we're going to do. We're actually going to multiply by negative 2 so we get a negative 6. All right, so I'm going to take and I'm going to rewrite this equation just right there. 4x plus 6y equals 18. And I'm going to take my blue one and I'm going to multiply it by negative 2. And I multiply every part by negative 2. So 10x times negative 2 is negative 20x. 3y times negative 2 is negative 6y. And negative 15 times negative 2 is positive 30. Now I can add these together because when I do, the y values are eliminated. 4x minus or plus a negative 20x, because I'm really adding them. So I could put parentheses around this and say I'm adding, but that's not necessary. So 4x plus a negative 20x is negative 16x, and I get a 0y equals 18 plus 30 is 48. Now I can divide by negative 16 to get my x by itself. And I'll get x is equal to negative 3. 48 divided by negative 16 is negative 3. Now I'm not finished. I have the x part of my coordinate pair, but I need the y part. And I can plug negative 3 in for x in either one of my equations in the x spot. It doesn't matter which one because what I'm finding is the coordinate pair that works for both. So plugging in x into either one of them will result in the same y value. So I'm going to plug into the red one here. So I have 4 times negative 3, plugging in negative 3 for x, plus 6y, whoops, I want to put that in red, plus 6y is equal to 18. Now to solve for y, 4 times negative 3 is negative 12, plus 6y equals 18. I'm going to add 12 to both sides to get my y value by itself. 18 plus 12 is 30. Now I divide by 6, and y is equal to 5. So my coordinate point, x equals negative 3, y equals 5. So my answer is negative 3, 5. And that's my solution right there. Let's have a look at the next one. Now in this one, again, I'm going to make a red and a blue. When I look at these, what I find is that I have 7x plus 3y equals negative 15, and 4x minus 4y equals negative 20. There isn't anything I can multiply my coefficients by to get the other one easily. So here's the easiest way to do these kinds of problems. Decide which coefficient you want to eliminate. I'm going to eliminate my y's again. So what I do is I look right here, and that tells me what to multiply this top equation by. So I'm going to multiply my top equation by 4. So I get, whoops, I should have used blue there. I'm going to multiply it by positive 4. So I get 28x plus 12y equals negative 60. So I multiplied each part of this equation by 4. Now, to figure out what to multiply this equation by, I look right there. So in both cases, I look in front of the variable that I'm eliminating and just use that, as long as one is positive and one is negative. Sometimes you'll need to multiply by a negative number. But in this case, I don't, because one is already positive and the other one's negative. So here I'm going to multiply by 3. So I'll get 12x minus 12y, and there you see right there, that's what I wanted, is equal to negative 60. Now I can add these two equations together. I'll get 40x is equal to negative 120. I can divide by 40 to isolate my x, and I'll get x is equal to negative 3. Now I plug that negative 3 into either one of my two equations for x, and then solve for y. This time I'll use the blue equation, not for any particular reason. 7 times negative 3 plus 3y equals negative 15. Now, 7 times negative 3 is negative 21, plus 3y equals negative 15. To isolate my y term, I'm going to add 21 to both sides. I get 3y equals 6. Dividing by 3, y equals 2. So my solution is negative 3, 2. Negative 3 is my x value. 2 is my y value. And that is systems of equations elimination.